I'm going to tell you something about the characteristics of blockchain and especially compared to other databases. I've made a drawing here of in 3 dimensions, which are the confidentiality, availability, and integrity. So these are the elements that are usually used to describe the security of systems. So that's 3 dimensions. If you compare a blockchain, then it's very high on integrity and also on availability. So higher than usual traditional databases. However, compared on confidentiality, it's a lot lower because it's publicly accessible. So especially in the integrity, that's a special function of blockchains that's really quite different than traditional databases. In this picture, I've put the database sort of in the middle. The integrity is usually quite good, availability also quite good, but not perfect, and confidentiality also quite good. As you notice that the confidentiality of a blockchain is pretty low, and there are alternative ways to increase the confidentiality. That's like the blue thing over here. So when you add encryption and zero knowledge proofs, you can improve the confidentiality. Well, the integrity of a blockchain is high in the way that there's a perfect audit trail of any writes to the blockchain. So anything you change on the blockchain is perfectly remembered. But you are able to change things on the blockchain. It's just that you can always see what has been changed. By the way, there's no audit trail for reads on the blockchain. If you compare that to traditional databases, there are audit trails for reads. So that's a difference over there. So nobody can change the state of a blockchain, especially the old state of a blockchain. For the future, you can change it. And what's also special about the blockchain, when you fix bugs in a blockchain, in a smart contract, you do that by redeploying the code. So there's also an audit trail of the code on the blockchain. You can always find back what used to be the code. Here on the confidentiality, it's very low, the confidentiality, because everybody can read everything. And what's also an aspect of that is that the smart contracts can be copied and can be reused on other places. And here on the top left, the availability is high from a blockchain. That's because there usually are lots and lots of nodes for the blockchain who can be accessed simultaneously. So that's usually a lot more than for traditional databases. So in a typical large blockchain, there could be like 10,000 nodes, which can be accessed. And in a traditional database, usually you just have a few nodes, depending on the type of database. Well, the performance of a blockchain, that's also compared to the traditional database. Especially the writing of data on a blockchain, that's pretty slow. So when you write something, it has to be put in a block. So with Bitcoin, it can take easily 10 minutes or more to wait for the next block. And for Ethereum, it takes at least 10-20 seconds for the next block, but it can also be that your updates are only put in one of the following blocks. So it could be a lot longer than 10 seconds. On the other way, the reading of a blockchain is pretty fast. You can immediately read anything from the blockchain, and also from a lot of nodes and simultaneously. So there is actually no limit on how fast you can read from a blockchain. And if you compare that to a traditional database, usually they are pretty fast for writing and reading both. They're pretty optimized on both those dimensions. Another way to look at it is when you look at the costs. So a traditional database, of course, the more data you put in it, the more expensive it gets. So this is sort of a linear growth. With the more data, the more expensive. And if you compare that to a blockchain, it's also kind of linear growth, but it's growing very rapidly. So it's very expensive to put a lot of data on the blockchain. So that's why you're not going to use a blockchain to put a lot of data on it, but only to put relatively small amounts of relatively important data. Well, a couple of other characteristics of blockchains. There is money involved with blockchain, so that means that any bug that you have usually very quickly turns into a security bug because some money can be stolen from even the smallest bugs. Anyone can deploy code on a blockchain, so that's quite different than normal databases. Normal databases are pretty closed and you cannot update the code on it. Maybe you can update data but not code. All the codes that you put on it, like smart contracts, can be interacted by everyone, so permissionless. So that's also quite different than normal. And even anyone can copy the entire chain, so-called the forking of a chain, and do with it whatever they want. A blockchain is a shared infrastructure. So the advantage of that you don't have to install your own database. You can just use the blockchain as it is. And you pay actually for the usage. So for every transaction that you do on the blockchain, you pay something that's called gas. So it's a pay per use kind of database. The side effect of a shared infrastructure is that you can be hindered by others, especially because shared really means shared by the whole world. So there are lots and lots of people using the blockchain. So you could even get a denial of service if too many people are using it. And the use of gas helps a little bit to alleviate that. So when you do lots of transactions, you also have to pay a lot of gas on it for it. Another special thing with blockchains is that you have to do your own key management. So you're yourself responsible for the key management. So that's different than from systems. Blockchains are also relatively immature, pretty complex and changing quite rapidly. So in practice, that means there are lots and lots of bugs. So you have to be pretty aware of that. You have to trust the cryptography of all the stuff on the blockchain, the protocols, the software, the network, the incentive mechanisms. So and there's not just one organization or person to blame if something goes wrong. The trust is gained by actually checking and proving all the interactions that are possible with the blockchain. So anyone can see how the blockchain works and show that it's working without having to rely on secret mechanisms. And when you design a blockchain, the incentive design around the blockchain, so who's doing what and who's earning what for doing what actions, is pretty important. So this is kind of an overview of the characteristics of a general public blockchain.